August 7th, 1942. The Solomon Islands chain stretched across the South Pacific like broken vertebrae, each island a potential fortress in Japan's southern perimeter. On Guadalcanal, the largest of these emerald fragments, morning mist clung to dense jungle canopies while waves crashed against black volcanic beaches. The air tasted of salt, rotting vegetation, and something else entirely, the metallic tang of impending war. Lieutenant Jack Cram stood on what would soon become Henderson Field, watching Navy Seabees hack through kunai grass with machetes that gleamed in the equatorial sun. Sweat streamed down faces blackened with mud and engine oil. Around him, the organized chaos of amphibious invasion unfolded in precisely choreographed disorder. Landing craft disgorged supplies, vehicles, and prefabricated structures onto beaches that had known only the footsteps of indigenous peoples and Japanese construction crews until 72 hours earlier. The morning heat already pressed like a wet blanket against every surface. Metal burned to the touch. Canvas sagged under moisture that seemed to rise from the earth itself. In this environment where humidity approached 100% and temperatures climbed past 90 degrees Fahrenheit before 10 in the morning, traditional military shelter faced an impossible challenge. Tents rotted within weeks. Wooden structures warped and split. Concrete cracked under thermal expansion and the relentless assault of tropical storms. But scattered among the conventional equipment, something different caught the filtered sunlight. Curved sections of galvanized steel, each piece stamped with manufacturing codes from factories in Pennsylvania and Ohio. These components, seemingly innocent in their industrial simplicity, would soon prove that American engineering could adapt faster than Japanese strategy could counter. The irony was not lost on intelligence officers monitoring radio intercepts from Rabaul. Japanese commanders, studying reconnaissance photographs of the American buildup, had identified these mysterious curved structures. In staff meetings held in concrete bunkers 800 miles to the northwest, senior officers examined grainy images with magnifying glasses, pointing at the semicircular silhouettes with a mixture of curiosity and contempt. Colonel Kiyoshi Tanaka, veteran of campaigns in China and the Dutch East Indies, dismissed the structures with a wave of his hand during a briefing to his bomber crews. The transcript, recovered decades later from captured archives, recorded his exact words. "Steel huts in the jungle. They will cook their own soldiers before we need to bomb them." Laughter filled the briefing room. These Americans, the officers agreed, had clearly never experienced the realities of tropical warfare. Their precious metal shelters would become ovens under the equatorial sun, forcing enemy troops into the open, where Japanese aircraft could eliminate them with ease. The disdain ran deeper than tactical assessment. Japanese military doctrine, refined through decades of expansion across Asia and the Pacific, emphasized adaptation to local conditions. Their forces used bamboo, captured materials, and natural shelter to blend with environments from Manchurian forests to Malayan jungles. The American approach, shipping prefabricated industrial structures halfway around the world, seemed to embody everything their propaganda portrayed about Western decadence and technological dependency. Radio operators in Rabaul forwarded intelligence summaries to Tokyo, describing American forces attempting to establish permanent installations using unsuitable metal construction. Staff officers noted with satisfaction that enemy morale would suffer as troops discovered the impossibility of finding comfort in steel furnaces. The Americans, they concluded, would learn the same lesson that had befallen European colonial forces throughout Southeast Asia. The tropics belonged to those who understood them. What Japanese intelligence failed to recognize was that these curved steel sections represented a revolution in military engineering born from American industrial capacity and systematic problem-solving. The Quonset hut emerged from urgent wartime necessity in 1941, when the U.S. Navy faced the challenge of rapidly deploying shelter systems to remote locations across two oceans simultaneously. Designed by the George A. Fuller Company in collaboration with Navy construction battalions, the Quonset hut solved multiple engineering problems with elegant simplicity. The semicircular cross-section provided maximum internal volume with minimum material usage while distributing structural loads evenly across the curved frame. Galvanized steel resisted corrosion in marine environments. The modular design allowed a complete structure to be manufactured in sections, shipped in standard cargo containers, and assembled by non-specialized personnel using basic tools. Each hut measured 16 feet in width and came in standardized lengths of 20, 36, or 48 feet. The arched framework consisted of steel ribs spaced 4 feet apart, connected by longitudinal steel strips that formed the distinctive corrugated exterior. Insulation, when available, was installed between the outer shell and an inner liner. Ventilation systems, crucial for tropical deployment, incorporated both natural airflow and mechanical circulation. The manufacturing process reflected American mass production principles refined by decades of automotive and appliance manufacturing. Factories in Davisville, Rhode Island, and other locations could produce hundreds of structures per week once production lines reached full capacity. Quality control ensured standardization. Any hut manufactured in Pennsylvania could be assembled using parts from Ohio factories. This interchangeability would prove crucial in combat conditions where damaged components needed immediate replacement. But theory and practice diverged sharply in the humid reality of Guadalcanal. The first Quonset huts arrived aboard transports during the initial invasion wave. Their steel components stacked like giant puzzle pieces between ammunition crates and medical supplies. Marines and Seabees tasked with assembly had never seen the structures before, working from instruction manuals that assumed temperate climate conditions and level ground. The jungle floor consisted of volcanic soil, decomposing vegetation, and subsurface water that turned everything into sucking mud during daily tropical downpours. Assembly crews struggled to establish level foundations using coral fragments and salvaged concrete. The galvanized steel, designed to resist corrosion, immediately began sweating condensation in the humid atmosphere. Without proper ventilation modifications, early huts trapped moisture like greenhouses. Lieutenant Cram, a mechanical engineer from Detroit before the war, found himself assigned to supervise the construction of maintenance facilities for Marine Fighter Squadron VMF 223. His background in automotive manufacturing gave him insights that pure military training could not provide. He recognized that the hut's industrial design principles were sound, but their tropical application required modification. Working with Sergeant Ray Morrison, a sheet metal worker from Chicago, Cram began experimenting with ventilation improvements. They cut additional openings in the curved walls, installed locally manufactured baffles to direct airflow, and used salvaged aircraft aluminum to create heat shields. These modifications, implemented without official authorization, transformed suffocating metal ovens into habitable structures. The improvised engineering attracted attention from other construction crews struggling with the same problems. Within weeks, unauthorized modifications spread across the base as practical solutions overcame regulation restrictions. The Quonset hut evolved from standardized factory product to locally adapted survival tool, embodying the same flexibility that characterized American forces throughout the Pacific Campaign. August 23, 1942 marked the first major test of these adaptations under combat conditions. Intelligence reports indicated a large Japanese air formation approaching from Rabaul, estimated arrival time near midnight. Henderson Field, still under construction, housed fewer than 30 operational aircraft, dispersed around the perimeter in improvised revetments. Ground crews worked frantically to refuel and rearm fighters while preparing for the inevitable bombardment. The newly constructed Quonset hut served multiple critical functions across the base. Communications equipment, including the primary radio transmitter linking Guadalcanal to Allied command centers, occupied a reinforced hut near the control tower. Maintenance facilities housed spare parts, tools, and technical manuals essential for keeping aircraft operational. Medical supplies and surgical equipment filled huts, designated as emergency treatment centers. Traditional military shelter, canvas tents, wooden buildings, and open-air facilities surrounded the steel structures. The contrast was stark. Curved metal surfaces reflected the afternoon sun like mirrors, while canvas sagged under accumulated moisture. To Japanese observers conducting reconnaissance flights, the mixed construction must have appeared chaotic, representing American inability to standardize their own equipment. At 23:40 hours, radar operators detected the approaching formation. 18 Mitsubishi G4M bombers escorted by Zero fighters. Air raid sirens wailed across Henderson Field as personnel scrambled for foxholes and reinforced positions. Blackout procedures plunged the base into darkness, broken only by the phosphorescent glow of instrument panels, and the distant flicker of navigation lights disappearing into clouds. The attack commenced with devastating precision. Japanese bombardiers, flying at 8,000 feet to avoid anti-aircraft fire, released their payloads in carefully coordinated patterns designed to achieve maximum destruction across the airfield complex. High explosive bombs cratered the runway. Incendiary devices ignited fuel storage areas and aircraft parked in the open. The coordinated assault represented textbook execution of strategic bombing principles developed during campaigns across China and Southeast Asia. Lieutenant Cram crouched in a maintenance hut with 6 other Marines as the bombardment intensified around them. The curved steel walls transmitted every explosion as vibrations that seemed to originate from the earth itself. Overhead lighting fixtures swayed with each detonation while tools rattled against metal shelving. The air filled with dust, and the acrid smell of cordite mixed with burning aviation gasoline. A direct hit on the fuel dump 200 yards away illuminated the entire base in orange light that penetrated through ventilation openings and around door frames. The explosion's concussion wave struck the hut like a physical blow, bending the steel walls inward before they snapped back to their original shape with a resonant metallic sound. Rivets strained against their holes but held. The galvanized coating, stressed by sudden temperature changes, released wisps of zinc vapor that created an ozone-like smell inside the structure. For 15 minutes, the bombardment continued with mechanical regularity. Japanese bombers flew predetermined patterns while their escorts circled overhead, watching for American fighters attempting to intervene. No Allied aircraft rose to challenge the attack. Those that survived the initial strikes lacked sufficient fuel or ammunition for effective resistance. Henderson Field appeared to be suffering the same fate that had befallen airfields across the Pacific during the first 8 months of war. When the last bomber disappeared into the northern darkness, silence fell across Guadalcanal with almost physical weight. Smoke drifted between burning structures while the distant sound of secondary explosions marked continuing destruction of ammunition and fuel supplies. The metallic taste of cordite mixed with salt air carried by trade winds that seemed to mock the devastation below. Lieutenant Cram pushed open the hut's steel door to survey the damage. What he discovered challenged every assumption about military construction in tropical environments. Traditional structures across the base had suffered catastrophic damage. Canvas tents reduced to smoking fragments, wooden buildings collapsed into splinters, concrete installations cracked and crumbling. But the Quonset huts, despite direct exposure to the bombardment, remained essentially intact. The curved steel construction had distributed explosive forces in ways that conventional architecture could not match. Blast waves that would have shattered straight walls followed the semicircular profile harmlessly around the structures. The galvanized coating, rather than being merely corrosion-resistant, had proven surprisingly effective at reflecting thermal radiation from nearby fires. Most importantly, the modular construction allowed damaged sections to be quickly identified and replaced without compromising overall structural integrity. Communications equipment inside the radio hut continued functioning throughout the attack, maintaining contact with Navy ships offshore and Allied command centers in Australia. Medical supplies remained undamaged and immediately available for treating wounded personnel. Machine shops housed in steel structures resumed operations within hours, fabricating replacement parts for aircraft damaged during the bombardment. The contrast with Japanese expectations could not have been more complete. Rather than forcing American troops into the open, the steel huts had provided superior protection while maintaining operational capability. Reconnaissance flights the following morning revealed that Henderson Field, despite extensive visible damage, remained functional as an operational base. Radio intercepts from Rabaul during the subsequent 48 hours revealed growing Japanese confusion about American resilience at Guadalcanal. Expected reports of base abandonment and troop evacuation never materialized. Instead, Allied aircraft continued operating from Henderson Field with increasing frequency, suggesting that the bombardment had failed to achieve its strategic objectives. Colonel Tanaka, reviewing reconnaissance photographs in his headquarters bunker, struggled to understand how American forces had survived what should have been a devastating attack. The steel structures, dismissed as impractical for tropical warfare, appeared undamaged in aerial imagery. Japanese intelligence officers began revising their assessments, but the process came too late to influence immediate tactical decisions. The psychological impact of survival extended far beyond physical protection. American troops, expecting to find their equipment destroyed and their positions untenable, instead discovered that industrial engineering could provide security even under the most extreme conditions. The Quonset huts became symbols of technological superiority and national commitment to victory, regardless of cost or complexity. Word of the successful defense spread throughout the Pacific Theater as reports reached engineering battalions preparing for future operations. The curved steel structures, initially viewed with skepticism by troops accustomed to traditional military architecture, gained acceptance as proven combat-effective equipment. Manufacturing priorities shifted to increase production capacity, while design modifications incorporated lessons learned under actual combat conditions. Sergeant Morrison, working alongside Lieutenant Cram to repair bombardment damage, noted that the galvanized steel showed remarkable resistance to tropical corrosion, even after exposure to extreme heat and chemical contamination from explosive residues. The prefabricated construction allowed rapid expansion of facilities as reinforcements arrived from New Zealand and Australia. Within 2 weeks of the initial attack, Henderson Field housed twice as many operational aircraft as before the bombardment. The strategic implications extended across the entire Solomon Islands campaign. Japanese forces, expecting to face demoralized troops operating from improvised positions, instead encountered increasingly sophisticated base infrastructure protected by proven shelter systems. Each subsequent bombardment demonstrated that American engineering could adapt faster than Japanese tactics could evolve. Production facilities in the United States responded to combat reports by accelerating manufacturing schedules and implementing design improvements based on field experience. Factories that had been producing civilian products 18 months earlier now operated 24-hour shifts, creating military structures tested under actual combat conditions. The industrial capacity that Japanese strategists had dismissed as irrelevant to Pacific warfare proved capable of supporting operations across vast ocean distances. By September 1942, Quonset huts had become standard equipment for American forces throughout the Pacific. Their success at Guadalcanal validated the entire concept of prefabricated construction for military applications. Engineering battalions received standardized assembly procedures, improved foundation techniques for tropical conditions, and specialized tools designed specifically for rapid deployment in combat zones. The curved steel structures appeared at newly captured bases from the Aleutian Islands to New Guinea, each installation proving that American industry could provide technological solutions to geographic and climate challenges that had historically favored local forces. Japanese commanders found themselves facing opponents who brought their entire industrial infrastructure with them, rather than depending on captured facilities or improvised construction. Lieutenant Cram, promoted to captain following his innovative modifications to standard designs, became part of a systematic effort to document and distribute field improvements throughout the Pacific Theater. His reports, filed with Navy construction battalions, contributed to design changes that improved ventilation, simplified assembly procedures, and reduced manufacturing costs without compromising structural integrity. The impact extended beyond immediate military applications. American troops, experiencing the effectiveness of prefabricated construction under extreme conditions, gained confidence in their nation's technological capabilities. The steel huts represented visible proof that industrial capacity, properly applied, could overcome traditional military disadvantages such as distance, climate, and hostile territory. Japanese intelligence services, monitoring American construction activities through reconnaissance flights and intercepted communications, began recognizing the strategic implications of prefabricated architecture. The enemy's ability to rapidly establish permanent installations at newly captured locations fundamentally altered the nature of Pacific warfare. Traditional assumptions about the time required to develop operational bases no longer applied when industrial products could be shipped and assembled faster than permanent fortifications could be constructed. October brought intensified Japanese efforts to neutralize Henderson Field through sustained bombardment campaigns designed to test American resilience beyond previous limits. Night attacks increased in frequency and intensity, with larger bomber formations escorted by additional fighter aircraft. The curved steel structures faced repeated trials under conditions that exceeded their original design specifications. Each attack provided additional validation of the engineering principles that had created the Quonset hut. Blast resistance, thermal protection, and structural flexibility proved superior to conventional military construction under combat conditions. More importantly, the modular design allowed rapid repair and expansion even during active operations. Damaged sections could be replaced without shutting down entire facilities, maintaining operational continuity that traditional architecture could not provide. The psychological warfare aspect became increasingly significant as Japanese propaganda struggled to explain continued American presence at locations that should have been untenable. Radio broadcasts from Tokyo claimed devastating success against enemy installations, but reconnaissance photographs showed expanding base infrastructure protected by structures that defied conventional military engineering assumptions. Captain Cram, now overseeing construction activities across multiple installations, observed that the Quonset huts had evolved beyond their original factory specifications. Field modifications developed at Guadalcanal had been incorporated into new manufacturing standards, creating improved versions that combined mass production efficiency with combat-proven adaptations. The structures represented successful integration of industrial design principles with practical military requirements under extreme conditions. American forces operating from steel-protected facilities maintained higher morale and operational effectiveness compared to troops using traditional shelter systems. The psychological impact of reliable protection influenced combat performance in ways that extended far beyond physical security. Personnel working inside structures that had survived repeated bombardments approached their duties with confidence that their equipment and supplies would remain available regardless of enemy action. Manufacturing capacity in the United States continued expanding to meet growing demand for prefabricated military structures throughout the Pacific Theater. Factories that had produced consumer goods before the war now specialized in components that would protect American troops in environments from Arctic tundra to tropical jungles. The industrial mobilization represented successful conversion of civilian production capacity to military requirements within less than 12 months of declaration of war. Quality control procedures, developed through automotive and appliance manufacturing, ensured consistent performance across thousands of structures deployed to remote locations. Standardization allowed interchangeable components, simplified maintenance procedures, and reduced logistical complexity for forces operating across vast ocean distances. The curved steel huts became symbols of American industrial capacity applied to military objectives with unprecedented efficiency. By November 1942, Japanese strategists recognized that their initial assessments of American technological capabilities had been fundamentally flawed. The enemy's ability to rapidly establish secure installations at newly captured locations represented a strategic advantage that traditional military doctrine could not counter effectively. Industrial production capacity, rather than being irrelevant to Pacific warfare, had become the decisive factor in determining operational success. The Guadalcanal campaign entered its final phase with American forces operating from installations that exceeded pre-war base facilities in sophistication and capability. The curved steel structures, initially dismissed as unsuitable for tropical conditions, had proven superior to permanent construction under combat conditions. Engineering solutions developed by industrial manufacturing had overcome geographic and climate challenges that military architecture had historically been unable to address effectively. Captain Cram, preparing to transfer to new construction projects in the Central Pacific, compiled final reports on Quonset hut performance under combat conditions. His documentation would influence military construction standards for the remainder of the war and establish design principles for prefabricated architecture that would continue influencing civilian construction decades after victory. The lessons learned under bombardment at Henderson Field had permanent value that extended far beyond immediate military applications. The curved steel walls that had protected Marines during those first desperate weeks on Guadalcanal represented more than successful engineering. They embodied American industrial capacity converted to military advantage through systematic problem-solving and technological innovation. The structures had become weapons of war as effective as aircraft or artillery, providing strategic capability that could not be countered by conventional military means. December brought final Japanese evacuation from Guadalcanal, marking the first major Allied victory in the Pacific Theater. Henderson Field, expanded and reinforced since those initial August landings, now housed hundreds of aircraft operating from installations protected by steel structures that had exceeded every performance expectation. The curved huts, battle-tested and proven effective, would continue protecting American forces as they advanced across the Pacific toward final victory. The Industrial Revolution that had created modern America found its ultimate expression in prefabricated structures that could be manufactured in Pennsylvania and assembled under bombardment in the Solomon Islands. Each curved steel section represented the collective capability of American manufacturing applied to military requirements with unprecedented efficiency and effectiveness. The huts were more than shelter. They were statements of national commitment to victory, regardless of cost or complexity. Years after the war ended, veterans would remember those nights when the sky burned orange above Henderson Field, while they crouched inside curved steel walls that deflected death itself. The sound of rain on galvanized metal would always remind them of survival, of protection provided by American industry applied to the defense of American lives. The Quonset huts had saved them when nothing else could, proving that steel shaped by free minds could not be broken by tyranny's bombs. The engineering principles that created those structures continued influencing construction decades after the last shot was fired. Prefabricated buildings, modular construction, and standardized components became fundamental elements of post-war development, from suburban housing to industrial facilities. The lessons learned under combat conditions at Guadalcanal contributed to technological advances that would rebuild a world devastated by 6 years of global warfare. But in August 1942, Lieutenant Jack Cram could not have imagined that his improvised ventilation modifications would contribute to victory in the largest war in human history. He simply recognized that American engineering could solve any problem when applied with intelligence and determination. The curved steel walls around him represented the same industrial capacity that would ultimately produce victory through superior technology, manufacturing efficiency, and unwavering commitment to freedom. The thunder of distant explosions faded into memory, but the steel stood eternal, a testament to the power of American industry applied to the defense of American ideals. In the end, tyranny learned that free nations could not be conquered when their factories produced shields as well as swords, when their engineers could adapt faster than their enemies could attack, when their steel was tempered by the unbreakable resolve to preserve liberty for future generations. History isn't just written, it's remembered through those who still care to listen. What story should we tell next? Subscribe to keep their memory alive. Your feedback is incredibly valuable and helps me keep making better content for you.